everyone, I am Gagan Ladda and today we are going to start a very important, a very basic subject of mechanical engineering branch, that is thermodynamics. Now this word thermodynamics is basically derived from two words. First is thermi, which is something related to heat, and second is dynamis, which is something related to motion or work. So back in 19th century, when the steam engine was first invented, it was invented accidentally, as we all know. Then we realized the potential of heat, we realized the importance of heat, we realized that heat can be converted into work. Later on there was a need to increase the efficiency of the steam engine as well. So all these necessities, all these needs leads to a new branch of science, which is nothing but thermodynamics. So initially the area of thermodynamics was very much confined. It was just concerned with converting heat into work and work into heat. But later on, as the time passed, the domain of thermodynamics is increased, and now we call this thermodynamics as science of energy transfer. So thermodynamics involves the science of energy transfer. Now if you ask me the application of thermodynamics in today's life, where can we see this thermodynamics? I would say where not. Suppose you are sitting in an office and you put on the fan, you are feeling hot, you put on the fan. The fan is a thermodynamic device. The fan is running from electricity. Electricity is generated in power plant. That actually is a thermodynamic application. You are traveling somewhere through automobile, through train, through anything. That engine of that train or that automobile is a thermodynamic device. You are using a refrigerator and an air conditioner in your home. That refrigerator or air conditioner is a thermodynamic device. So everywhere, in fact our human body is also a thermodynamic device. This is constantly emitting the energy in the form of heat. So we can find the application of thermodynamics in each and every step of our life. We cannot imagine our life without thermodynamics. So now the question arises, when the domain of this subject is too vast, then what are we going to study in this particular subject? Okay, because we cannot study about each and every phenomenon occurring in this universe. So what are we going to study? So since the evolution of this mankind, we need to understand that each and every activities which are occurring in the nature, we started observing that, and we came to the conclusion that those are not random activities. ये कोई random activities नहीं है जो जब जिसका मन चाहे वो हो गए. All those activities are related to, all those activities are bound by certain laws. Those laws we named as the laws of physics, laws of thermodynamics, laws of nature. Okay, so whatever activities are happening in the energy conversion, during energy conversion, so all those activities are somewhere or the other bound by certain laws, few laws. Those laws are known as laws of thermodynamics. Now for example, suppose initially the plant, we are having a small plant, धीरे 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 करके वो बड़ा होता है, एक ट्री में कन्वर्ट होता है. बट द रिवर्स प्रोसेस नॉट पॉसिबल. बड़े से प्लांट छोटा नहीं हो सकता. ह्यूमन बीइंग का बच्चा पैदा होता है, छोटे से बड़ा होता है, बट बड़े से छोटा नहीं होता. That means reverse of some process is not possible, governed by second law of thermodynamics. If I leave some object in the at certain height, it will fall down. The water falls from high potential to low potential, high height to low height. The heat flows from high temperature to low temperature. Wind flows from high pressure region to low pressure region. All such things are governed by second law of thermodynamics. The phenomena are different, but the logic behind them, the principle behind them is same, which is second law of thermodynamics. Suppose a rock is rolling down the mountain and it hits other rock, and the first rock stops and other rock starts moving. This is governed by law of energy conservation, first law of thermodynamics. Similarly, plant takes sunlight in order to in the process of photosynthesis, and they provide fruit to us. We eat fruit and that energy is transferred to us. This is again governed by first law of thermodynamics, law of energy conservation. So all such phenomena, there are numerous examples. जितने भी आप phenomena you can see, all those phenomena are actually bound by few laws. Okay, the different applications, as I told you, is like the different branches and different leaves of the tree. Okay, but all those leaves are ultimately bounded by the root of that tree, and that root is nothing but the laws of thermodynamics. Okay, so किसी tree को अगर हमको किसी plant को हमको feed करना है, so we do not feed each and every leaves and each and every branches. हम क्या करते हैं? We feed the root. okay, and that nutrient is ultimately transferred to each and every branches, each and every leaves. Similarly, if we want to understand all the phenomenons, what we have to do is we just have to understand those few laws. And understanding those few laws, those are called as laws of thermodynamics, that we are going to do in this particular subject. Now basically there are two different approaches to study thermodynamics. First is the macroscopic approach, which is called as the classical thermodynamics, and second is the microscopic approach, which is also called as statistical thermodynamics. Now what is macroscopic approach? Macro means something which is big, micro means something which is small. So what is macroscopic approach? Macroscopic approach means when the system is considered as a whole, when the behavior of the system is studied as the net effect of the behavior of all the molecules, then that approach is called as the macroscopic approach. And when the behavior of system is studied as the individual behavior of the molecules present in it, okay, then that approach is known as the microscopic approach. I will give you one example. Suppose the macroscopic approach means something which is which can be felt, which can be seen by our human senses. For example, suppose I have a piston cylinder device, for example, and if I ask you the temperature of the system, you will just put one thermometer and you will tell that the temperature of the system is suppose T1 degree centigrade. The pressure of the system, you will just put a pressure gauge, you will tell the pressure of the system is suppose P1 bar or P1 kilopascal. Okay, irrespective of the fact that what was the reason for that temperature or what was the reason for that pressure. If I supply heat into it, the temperature would increase. Okay, now what is the reason of increase of temperature? Now because when the heat is supplied to the system, the molecules of the gas will start moving with a faster pace. The energy of the heat is transferred to those molecules, and that is converted to kinetic energy of the molecules. Okay, and they will start moving with the faster pace, they will collide with each other, and finally the temperature of the system will increase. So when we are getting into the detailings of in the molecular level, then that approach comes under the microscopic approach. And when we are concerned with just the system as a whole, we are not concerned with the molecular level, then that approach is known as the macroscopic approach. This is the basic difference between the macroscopic and microscopic approach. And one thing you must understand, that the macroscopic approach is something which is fact, which is truth, which can be seen, which can be fact. Microscopic approach is just a concept which is used to explain the final result, which is actually the macroscopic properties. Okay, so for example, as I told you about the pressure, if the pressure is increasing, that means somewhere or the other the molecular momentum exchange is increasing. The pressure is because of molecular momentum exchange, but that is actually the concept, because no one has get into the molecular level. Okay, so कल के दिन हो सकता है कि माइक्रोस्कोपिक अप्रोच के कुछ कंसेप्ट चेंज हो जाए, कुछ सेंटेंस चेंज कर दें, जो पहले के कंसेप्ट है डेट वाज एक्चुअली लॉजिकल एंड एक्सेप्टेबल, तो हमने उसको एक्सेप्ट कर दिया. इफ समवन कम्स की आई एम कमिंग विद अ डिफरेंट थ्योरी, so his theory should actually define the end result. Whatever theory he is giving at the microscopic level, that should actually define the macroscopic properties, because the final result is macroscopic properties, which is actually seen, which is truth, which can be seen, which can be felt. Okay, so this macroscopic approach, as I told you, is called as the classical thermodynamics, and microscopic approach is of this studying this thermodynamics is called as the statistical thermodynamics. So these are two approaches. Now coming to basic definitions, some definitions. First is thermodynamic system, surrounding and boundary. Now what is a system? Now the part of the universe which is taken for the thermodynamic study, thermodynamic analysis, that a small part is known as the thermodynamic system. Now apart from this system, the rest of the universe is called as surrounding, and the imaginary boundary which is separating the system from the surrounding is called as boundary. Okay, so the system is a small part of universe which is taken for thermodynamic study, thermodynamic analysis, and apart from that system, the whole universe is the surrounding, and obviously system plus surrounding together comprise a universe, and the imaginary boundary which separates system from surrounding is known as boundary. So this is the system, surrounding and boundary. Now coming to the types of system. Now basically this system is of three types. First is closed system, second is open system, and third is isolated system. Now what is a closed system? Closed system means there can be the transfer of energy, but there cannot be transfer of mass. Closed system, that means mass of the system cannot transfer. Only energy of the system can transfer. It may be in the form of heat, it may be in the form of work. For example, a piston cylinder arrangement, as I gave you the example. Suppose heat is transferred to this piston cylinder arrangement and this piston is moving up doing certain work. Okay, so energy is transferred in the form of heat and in the form of work, but the mass is confined inside the piston, inside the piston cylinder arrangement. Okay, mass is not changing, only the energy is transferring. Such a device, such a system is called as closed system. Okay. Now, second is the open system. Open system means both energy and mass transfers across the boundary, that is called as open system. For example, the turbine. Okay, in turbine what happens, continuously mass of the steam is getting in, continuously mass is getting out, so the mass is getting transferred. Now, apart from this, that turbine is producing certain work, that means energy is also transferred. So, both mass as well as energy is transferred. Such system is known as open system. And what is isolated system? The system in which neither mass nor energy transfer takes place, that system is known as isolated system. For example, thermos flask. If you have seen the thermos flask, okay, that is designed in such a way that no heat is transferred outside or no heat gets inside. Okay, that is actually an isolated system. Okay, and now there is a difference between isolated and insulated system. Okay, just understand this thing. Isolated system means neither mass nor energy transfer takes place. Nor energy transfer means neither heat transfer nor work transfer. Neither form of energy transfer takes place, and not the mass transfer takes place. Such system is known as isolated system. What is an insulated system? Insulated system means the heat transfer cannot take place. Now, there may be some work transfer. Now, this insulation is used in many machineries, used in industries, जहाँ पर there can be energy transfer in the form of heat, वहाँ पर हम use करते हैं this insulation so as to prevent that energy. For example, turbines को insulate किया जाता है. There are heat exchangers को insulate किया जाता है. Otherwise, वो energy which has to be converted into work, उसका some part loss हो जाएगा in the form of heat, which actually is not expected from it. Okay, so this is the difference between insulation and isolation. Isolation means neither mass transfer nor energy transfer takes place. Next, coming to the control volume and control surface. Now, as I told you, in closed system the mass is confined, and because the mass is confined, the boundary is almost defined, and that boundary either may change. If the system is expanding, the boundary may change, but inside that boundary we are having that confined mass. So, the study is quite simple. But what about open system? In open system, the mass actually is not confined. So, how can we define the boundary? So, we take an imaginary surface around our system, around our open system, such that the energy is continuously getting into that system, energy continuously gets out of the system, mass is continuously getting into the system, mass continuously gets out of the system. So, that imaginary surface is called as the control surface, and the volume inside that imaginary surface is known as control volume. So, what is a control volume? In open system, we imagine a certain surface such that energy and mass continuously gets inside that surface, continuously gets outside that surface. That surface, imaginary surface around that open system is known as control surface, and the total volume inside that control surface is known as control volume. Okay. Next, coming to the property of a system. Now, what is the property of the system? Properties are those unique characteristics of the system which are used to define the state, a particular state of the system. That is known as the property of the system. For example, if I want to define a certain state of any system, what will be the characteristics which are used to define? Now, the characteristics would be the temperature, the pressure of the system, the color of the system, the composition, chemical composition, the volume of the system. All such characteristics which are used to define a certain state of the system is known as the property of the system. If the state of the system will change, obviously the property will change. If the state is changing from, suppose, state 1 to state 2, the properties will be changed. Maybe the pressure will change, or temperature will change, or volume will change, or whatever. Okay, so the properties are the unique characteristics which are used to define the state of a particular system. Now, what are the features of these properties? The very first feature is these are the measurable characteristics which describes any system. The measurable characteristics describing any system. Next, these are having a definite value at any particular state. The properties are having definite value at a particular state. The properties do not depend on the path followed by the system. These are point function. We will get into this point function and path function. So these properties do not depend on the path the system follows. And last thing, for these properties the differential should be exact. This also I will get into this, that what is the meaning of this exact differential. Okay. Now there are basically two types of properties. One is intensive property and second is extensive property. Now what are intensive properties? The properties which are independent of mass. That means ऐसी properties जो कि mass पे depend नहीं करती है. All those properties are known as intensive properties. For example, temperature. Temperature is independent of mass. Okay. Pressure, it is independent of mass. Density. Now what is density? Density, as we define, is mass per unit volume. Now because density is mass per unit volume, whether it depends on mass or it does not depends on mass, the density does not depends on mass. Okay, just understand this thing, that because density is mass per unit volume, एक unit volume में कितना mass है. Now whether that volume be 1 meter cube or whether that volume be 10 meter cube, whether that mass is 1 kg, whether that mass is 10 kg, ultimately हमको देखना है कि 1 meter cube में कितना mass आ रहा है. That is nothing but density. So this density is actually an intensive property, not an extensive property. Density does not depend on mass. Density of water is 1000 kg per meter cube, whether it be 1 kg of water or it be 100 kg of water or whether it be 1000 kg of water, the density will remain same, which is 1000 kg per meter cube. So density is an intensive property. Apart from this, viscosity, thermal conductivity, all such properties which does not depend on mass are known as intensive property. Now coming to extensive property, extensive properties are the properties which depends on mass. For example, volume. Volume depends on mass. For example, energy, the kinetic energy, potential energy, half mv square mgh, whatever properties depends on mass is known as extensive properties. Now one thing to note here is all specific extensive properties are intensive properties. For example, the volume is an extensive property. Specific volume is an intensive property. Specific volume means volume per unit mass. That means 1 kg mass में कितनी volume आ रही है. Now whether it be 1 kg or whether it be 10 kg, ultimately specific volume will remain constant. Okay, so specific volume was an extensive property, and specific volume will be an intensive property. Similarly, the energy, kinetic energy is extensive property, half mv square. Specific kinetic energy, half mv square divided by m, which is half v square, is an intensive property. Potential energy is extensive property, specific potential energy is an intensive property. So all specific extensive properties are